Every organ, every wrinkle, every fading heartbeat can be traced back to the same scale, the life of the cell. Aging is not just about joint stiffening or memory fading. It begins when trillions of cells lose their ability to repair, renew, and divide. The question that has haunted science for decades is simple. Can this cellular clock be reset? In the 1960s, scientist Leonard Hayflick made a startling discovery. Human cells grown in a dish divided only about 50 times before stopping, a limit now called the Hayflick limit. Contrary to the earlier belief that cells were immortal, he revealed that they carried an internal countdown. The secret lay in telomeres, protective caps at the ends of chromosomes. Each time a cell divides, its telomeres shorten like the tips of shoelaces fraying with use. When they become too short, the cell enters senescence, alive but unable to divide. Senescent cells accumulate with age, releasing inflammatory molecules that poison surrounding tissue, contributing to frailty and disease. The story might have ended there, except for one twist: telomerase. In the 1980s and 1990s, researchers discovered this enzyme could restore telomeres, effectively winding the clock backward. Cells once considered old began dividing again, expressing youthful patterns. In essence, the cellular aging process was not fixed. It could be reversed. The implications are enormous. If telomerase can reset the cellular clock, then tissues and organs might be renewed. Animal experiments support this idea. Mice treated with telomerase gene therapy regained fertility, improved organ function, and even extended their lifespans. Fossil compares this to the discovery of germ theory, an insight so profound it could redefine all of medicine. Yet, the promise comes with peril. Cancer cells also exploit telomerase, using it to divide endlessly. Any therapy that restores telomeres must also guard against fueling malignancy. The challenge is to harness rejuvenation without unleashing uncontrolled growth. Still, the principle is established. Aging is not simply wear and tear. It is driven by a molecular mechanism we can, in theory, control. Just as early airplanes proved human flight was possible, even if they were fragile and clumsy, early telomere research proves rejuvenation is real, even if crude today. The vision Fossil outlines is bold, a future where doctors don't just treat Alzheimer's or heart disease separately, but reset the cellular clock that underlies them all. To reverse telomere shortening is to strike at the root of aging itself. For the first time in history, humanity stands not only to delay aging, but to undo it, to turn back the biological clock at its deepest level. The challenge now is to refine the tools, ensure their safety, and decide what it means to live in a world where time itself may be negotiable.